So children, depending on the shape depending on the shape of the spherical surface of the lens, the lens have been categorized. For example, if you see the first one, in this both the surfaces they are spherical and they are such that the middle part is thicker as compared to the edges. So this is your double convex lens, which in simple terms we call it as convex lens, right? This is your convex lens, simple convex lens. Now, if you see the second diagram, in the second diagram, you will see that one surface is spherical, yes, and the surface is such that its center in middle it is thick as compared to the edges, and in the edges it is thin. So it is convex lens, yes. But the other surface is plane. So this is your plano-convex lens. This is a type of convex lens. And if you see the third type of convex lens, you will see that the one surface that is convex, right? That is convex, that is it is bulging outwards. But the other spherical surface is inside, bulging inside, right children? So this is known as concavo convex lens. This is your concavo convex lens. Now next you can see the types of concave lens. Now this is your concave lens, right? The concave lens is in the middle it is thin and at the edges it is thick. So this is your double convex lens, double concave lens, which in simple terms you call it as, we call it as concave lens, right? We call it as concave lens. The second type of concave lens is, here you can see that the one surface, yes, it is your concave, but the other surface is your convex. So this is a combination of concave and convex, right? But finally, in the middle it is thin and at the edges it is thick. So this is a type of concave lens, but it is known as your convexo-concave lens, right beta? Now third type of concave lens is, this is your concave, this spherical side is your concave side, right? Because it is bulging inwards, and it is thin in the middle and it is thick at the edges, right children? But the other spherical side, the other spherical side, that is the other your spherical side is plane. The shape of the other side is plane, so it is known as your plano concave lens. So these are the three types of concave lens. Next, let's start with a few terms, and firstly we are going to start with the center of curvature of a lens. Now here we can see that this side, this spherical side of a convex lens is the part of the sphere. इस sphere में से इसे cut किया होगा. So this side of your convex lens is cut from a spherical sphere, right? Similarly, the other spherical side, that is this side. This side is cut from another spherical, is a part of another spherical sphere, right? So both the surfaces of lens, दोनों जो lens की surface है कैसी है, spherical है. So both the spherical surface of lens, they are the part of a sphere. वो किसी sphere में से cut करके बनाई गई है. They are part of some sphere जिसमें से उसे cut करके बनाया गया है, right? So how it is? The spherical surface of lens, जो spherical surface है lens की, they are the part of, किसका part है? They are the part of spheres. They are the part of this red spherical surface is a part of this sphere. The yellow spherical surface, this yellow spherical surface is a part of this sphere, right? So both the spherical surface, they are a part of spheres, right? Now these spheres, they have center. These spheres, both the spheres, they are having centers. right? So this is your, suppose this is your C1, and suppose this center we call it C2. So the center of the sphere of which the spherical surface of a lens forms a part is called center of curvature, right? Either you can start with that or you can start with your spherical surface. आपके पास क्या है? You have the spherical surface of the lens, right? So you can start with that. Or how we will start? The spherical surface of the lens is a part of a sphere. वो sphere का part है, right? So the spherical surface of a lens, spherical surface किसकी है? Lens की है. So the spherical surface of a lens is a part of a sphere. Now this sphere has a center which is known as center of curvature. So the lens have two center of curvature. This is C1 and this is your C2. So this is your definition of center of curvature, that is each of the spherical surface of a lens, it forms a part of sphere, and this sphere has a center which is known as center of curvature. Right, children? Now let's talk about the next term, that is optical center. Optical center, as in mirrors we had done pole. Pole was the center. Pole was the center of your mirror, right? Centermost point of the mirror. Similarly, your optical center is also the center. It is also the center of the lens, right? Optical center is also the point which is at the center of the lens. ये भी center of the lens पे है, right? और अगर इसमें से बेटा any light rays passing, then that light ray will pass straight. It won't get deviated. No refraction, nothing, right? So optical center, what it is the center of a lens. First point, it is the center of the lens. Second, if any incident ray passes through this point, right, then it passes undeviated. For example, if I draw a ray from the optical center over here. So suppose if I draw the ray like this, then this ray which is passing through the optical center, it is going to pass undeviated. There would be no refraction if the light is passing through the center of the lens, that is if it is passing through the optical center. Next is your principal axis. Very well known term, we know. Principal axis, as you can see on your screen, it is an imaginary line that is joining the center of curvatures of the lens. Now as we know, we are having two center of curvatures, C1 and C2. So it is that line which is joining or which is passing through the centers of curvature of the lens. It is an imaginary line, it is no real line. Right, Pita? And this principal axis line is perpendicular to the lens, right? It is perpendicular to the lens. This you should know, right? So what is principal axis? Principal axis is an imaginary line which is passing through both the center of curvatures of the lens, right? This they have shown in your concave lens and this is shown in convex lens. Next, very important term in 2 marks, this question comes in your exam, that is about the principal focus. That is about the principal, that is about your principal focus, right? I have written only focus over here. This is principal focus. We are aware of the term, right? Principal focus. So, convex lens, if you remember, the other name of the convex lens was converging lens, right? It is going to converge all the rays which are parallel at one point. So, how you are going to define your principal focus? So, as you see over here, that the incident light rays, these rays, they are parallel to the principal axis. Yes, we can see them that they are parallel to the yellow color principal axis. Yes. Now what will happen? When they are going to enter the lens, the refraction is going to take place. Due to the refraction of light, all the rays, they are going to converge at a point. So you can see here that the rays which were parallel to principal axis, after refraction, they are converging, they are meeting at a point, right? They are meeting at a point, they are converging at a point, and this point is known as principal focus. So here the rays are actually meeting after refraction, right? So what is your principal focus? As you can see, your principal focus is a principal focus. Yes, there are two focus in a lens, you are true, right? But we are going to consider that our object is always placed on the left. We are going to consider it that the object is placed from the left. So our incident rays are going to come from the left. So in that case, we are going to consider towards the principal focus on the right side, right children? So here, principal focus, what it is? It is a point on principal axis. First thing, it is a point on principal axis. जो principal focus है, as you can see that it is a point, and this point, as you can see, it is on the principal axis, right? Now, fine. This is a point on principal axis where the incident rays actually meet, incident rays actually meet करती हैं, but after refraction, so once again beta, principal focus is a point on principal axis, yes, where the incident rays parallel to principal axis actually meet. जो parallel incident rays हैं, parallel किसको? To principal axis, they actually meet after refraction. After refraction is very, very important, right? After refraction, the rays are going to meet, right children? So this is your definition of principal focus. That is, principal focus of a convex lens is a point on principal axis where all the incident light rays parallel to principal axis. कौन से incident light rays? Which are parallel to principal axis. They actually meet after refraction. Right children? This was your principal focus for convex lens. Similarly, we are going to have the principal focus for concave lens. And in concave lens, the incident rays, they are going to diverge, right? Let's see that part also. Next is your principal focus for your concave lens. Principal focus for your concave lens, right? So here also children, as you can see, we are considering those light rays which are parallel to principal axis, right? These light rays are parallel to principal axis, right? Now what will happen when they are going to when they would undergo refraction, right? So after refraction, what will happen? They are not going to meet at a point. Actually, they are not going to meet. Why? Because as you know, this is a diverging lens. Diverging lens में क्या करेगा? It is going to spread out the light, right? It is going to spread out the light. So what will happen after refraction? The incident rays which are parallel to principal axis, after refraction, they are going to diverge like this. Now, if you see these refracted rays, red color refracted rays, they are never going to meet each other, right? So actually they are not meeting, right? What we are doing, as in mirror also we did. So what we are going to do is, we are going to extend these rays in the backward direction, right? We are going to extend it in the backward direction. So on extending it in the backward direction, we see they appears to meet at a point. They appears to meet at a point, and this point is known as your principal focus. This point is known as your principal focus. So this is your principal focus for concave lens. So how we are going to define? Again, principal focus is a point on principal axis. Yes, it is a point on principal axis, right? Where all the incident rays which are parallel to principal axis, we are not going to write the word meet. We will use the word that is appears to meet, right? Appears to meet after refraction from the lens. So this is your principal focus for concave lens, which is also known as diverging lens. So this is your definition, actually. Next is your focal length. So as we did in mirror also, same over here. Focal length, that is the distance between, that is the distance between your optical center O, आपने यहाँ पे optical center है, right? As we know, at the center of the lens. Let me zoom it, children. Just a second. Okay. If I zoom it like this, right? Then optical center is over here. Optical center is a point here. So this is optical center, right? So the distance between the optical center and the principal focus F, this is your O and F. So the distance between the optical center and the principal focus of the lens is known as your focal length small f. Is known as your focal length small f. So focal length is the distance between the optical center and the principal focus. Okay. Next is your aperture. Aperture we have done in mirror also. Aperture was the diameter, right? Here also the diameter of the lens, right? The diameter of the spherical lens, the outer portion of the spherical lens. For example, as you can see in the picture, this is the lens. So this part, this diameter of the outer boundary of the outer surface of the lens, that is known as aperture. So here you can see in the picture very nicely they have shown you aperture, that is the diameter of your spherical surface of the lens. That is aperture. Okay, now in mirror also I told you that whenever you're going to draw the ray diagrams, you have to use the measurements. Measurements are very, very important when you draw the ray diagrams. Right, children? So what you need to do is you need to mark first the optical center O. Mark down the optical center O. And from optical center O, you can take 2 centimeter distance on both the sides, and on the left that is F1, that is principal focus 1 F1, and on the right side at again 2 centimeter you should mark the point F2, and from F2 I know we are going to mark the point C2. C2 is what? Center of curvature. But instead of writing C2, you can also write 2F2. No problem in that, because that we know that it is double of the focal length, right? It is double. So this should be, if this is at 2 centimeters, then this should be at 4 centimeters, right? So for in your NCRT for the lens, they are not using the terms. They have written C1, C2 as well. You can write it, but they have used the word 2F2. So no problem. We can also write 2F2. That is not a big deal. But what I mean to tell you that you need to mark these points with proper measurements. Once you take proper measurements, then only the ray diagrams will be possible, right? You will get accurate ray diagrams. After marking down these points, you have to draw the lens, and that lens should be very, very thin, right? Try to draw the lens very, very thin. It should be very, very thin, right? Whether it is a convex lens or it is a concave lens. Okay, children? So I think we will stop here. Okay, beta. Thank you. Bye bye. Take care.
Thank you, ma'am.
Bye, beta.